Hi, I'm Amanda, and today we're going to go over some practice problems on determining empirical formulas. So for our first example, we know the moles of each element that we have. So this compound has 6.7 moles of nitrogen and 10.1 moles of oxygen. So to determine the empirical formula, we'll put the moles as the subscript, and then we'll divide by the smallest one that we have. So that would be 6.7. So we end up with a subscript of 1 on N, and on O we end up with 1.5. Now because we need all of the subscripts to be whole numbers, we'll multiply the whole thing by 2, and we'll get N2O3. So that's our empirical formula. For our second compound, we know the grams, but not the number of moles. So we have 136 grams of oxygen and 71.5 grams of nitrogen. So we have 136 grams of oxygen. The molar mass of oxygen is 16.00 grams. If we divide this number by the molar mass, then we end up with 8.5 moles of oxygen. Now we'll do the same thing with the nitrogen. The molar mass of nitrogen is 14.01 grams. So if we divide this by the molar mass, we end up with 5.1 moles of nitrogen. Now we're going to divide by the smallest number that we have here. So if we divide both of these by 5.1, then we'll get 1 mole of nitrogen and 1.67 moles of oxygen. Now because again we need whole numbers, we'll multiply both of these by 3, and we'll end up with an empirical formula of N3O5. So that's our empirical formula for this compound. In the third compound, we only know the mass percentages of each element. So to do this problem, we're going to assume that we have 100 grams of the compound. That way we don't have to multiply our percentages by anything. So we'll start off with 43.69 grams of sulfur. The molar mass of sulfur is 32.06 grams per 1 mole. If we multiply that out, we get 1.36 moles of sulfur. Now we'll do phosphorus. We have 56.31 grams, and the molar mass of phosphorus is 30.97 grams per mole. If we multiply that out, we have 1.82 moles of phosphorus. Again, we're going to divide both these numbers by the smallest one, which will be 1.36, and we'll get 1 mole of sulfur and 1.34 moles of phosphorus. Again, because we need whole numbers, we'll multiply both of these by 3. And we will end up with 4 moles of phosphorus and 3 moles of sulfur. So our final empirical formula is P4S3.